ಯಾರು ಹೌದಾ ಇದು ಯಾಕೋ ಇದು 10 ವರ್ಷ ಸೆಲ್ ಡೌನ್ ಅದೇ ಅಲ್ಲಿ ಇವತ್ತರ ನೆಟ್ಗೆ ಪ್ರಾಪರ್ ನಿನ್ನೆ ರಾತ್ ಹಾಂ ಹಾಂ ಥ್ಯಾಂಕ್ ಯು. Yeah, in continuation with yesterday's sensor class, we'll go ahead with chemical sensors today. Now basically chemical sensors, you can see that for measurement of chemical properties of substances and chemical compounds, these chemical compounds are called here as analytes in solids, liquids, gases, in all the forms. So properties of substances and chemical compounds, basically to test if there is any variation in the chemical compound compared with the standard one. Always the sensors, they basically test or check the change and then they report it. So here basically the chemical composition of certain things, say suppose air, chemical composition of air is supposed to be so much. If there is any variation in that, then that has to be reported. So, in usual common example is the gas masks or the gas sensors. They basically test the chemical composition of the gases, and if anything is above or below that level, then that is notified here. So in all these chemical sensors, basically they are compared with a standard level, and anything above or below is reported in the sensor. So all these are digital and they take the change and then it is reported, or again in the electrical form, electrical signals, or in the mechanical form it is reported. Usually the electrical ones are preferred because they are faster, and online and real time analysis, these are preferred. So in all solids, liquids and gases, the chemical composition is checked. So used for both organic and inorganic mixtures or compounds. Now why the mixture is, sometimes they may not form the compounds, so they may be hazardous to our health. Suppose the acid rain and all. Now acid rain, along with water it falls, so you don't even know how much acid quantity or acid level is present in that. So if you start suddenly, some kids and all, if they start drinking, it may be hazardous to them. So to test such things, it is used for measurement of, and it is not necessarily a compound. It has not already formed a compound. There is no chemical compound formation, but it is simply a mixture. So gas and water, they are mixed. So it is still not formed a compound. So under such cases, even in the organic mixtures and compounds, this should be available for usage. And in examples are, see, fertilizers, not necessarily compounds are there. Fertilizers, some of them may be compounds of potassium, nitrogen, oxygen, all those things, and some of them, they may be simply a mixture. The organic composts are simply the mixtures of some leaves or even the fish, dried fishes and all. So such mixtures, each percentage is how much. To test that, these chemical sensors are used. Now even in pesticides, herbicides, all these food products, wines, beverages, scents, cosmetic, petrochemicals, all these, that's why I said all these are often we use them, but if a certain level is crossed, then definitely they are hazardous to human beings as well as the creatures or animals around us. So in general, to the atmosphere, they are hazardous, so chemical sensors are used. The most commonly used one in these days is kitchen gas sensor. If there is any gas leakage, immediately it is sensed through these chemical sensors. Sometimes even the biosensors are also used there. That we'll see little later. So basically used for both organic and inorganic. And the examples are for mixtures. Fertilizer is a good mixture. pesticides, herbicides, they are also good mixed. But wines, beverages and all, they usually form the compounds. They are not mixtures, they are compounds. They are used in commonly medical, automotive, nanotechnology, home detection systems. That is what I said. Home detection, basically the gas analyzer, or even the alcohol breath analyzer. So basically, with the help of the breath analyzer, you will be able to know whether the person has had the alcohol at above certain level. If it is within the limit, again some of them they may not detect, but above certain level, above danger levels, it is very easily detected. So online analysis is preferred. Now what exactly online or real-time analysis? Immediately when I am driving, had alcohol, then what happens? Naturally a police person comes and tests me. Okay, if I have had alcohol above certain dangerous levels, then immediately it will be notified. So this is a online and real time. Online means this can be sent immediately through a computer to anywhere. So this is the advantage of having online sensors. Now such more than 10,000 products are required in sensing. Now what exactly, you can see the volume, like how many 10,000s of sensors are being used daily for sensing variety of products. So challenge is to develop these many sensors and sensing techniques. Now I'll take one example. Suppose in a fertilizer, what I said is fertilizer may not be a compound always. It may be a mixture of different components required there. Say nitrogen is required, potassium is required, phosphorus is required, plus oxygen or carbon compounds. So when you have a mixture like this, when it comes in contact with the soil, some chemical reaction may happen. And due to that, the pH level and all, they may vary. And when you add water, it may get diluted. In some cases, some gases may be escaped out. So under such cases, some compounds are there, some mixtures are there. So simultaneously to cater to the needs. So you need different technologies there. Now if it was a compound, then you would immediately check the level of certain substances what are going to be released after the chemical reaction, and it would be easy to detect those particular gases which are being liberated. But if it is a mixture, unless it gets mixed, you will not know what is the composition. Sometimes, see, simple or chili powder, it is adulterated, we say. It is mixed with some wood powder or some colors and all. So how do you check such a thing? So it is poured in water, and if lighter material comes out, then they say that okay, it is adulterated. So many other things are there. So like this, testing of a mixture is not that easy. So naturally, to test such mixtures or to sense such mixtures and check what is the required level, whether it is available in that or no, you have lot of challenges there. Plus the technology adopted to test these things are very, very different. So challenge to develop these many sensors. First you have to develop the sensor to check the mixtures or separate out the mixtures and compounds and then give a result. Plus the technology used also is different. From one sensor to another sensor, technology variations may be there. Now for this, that's what the challenge is, to develop these many sensors and sensing techniques. Next thing, the next point is mainly ceramic, semiconductor, polymer sensors are developed. So these are the ones which are used using our advanced technologies. Now ceramics, semiconductors, all these you can see they are all low cost materials. So naturally all these sensors are very, very low in cost compared to our old sensors or transducers. Say for example LVDT, which was used to check the distance or the displacements. Nowadays to check the displacement or distance we are using simply the proximity sensor or IR sensor. So these are very, very low in cost, plus they give accurate results. But LVDT is bigger in size, but these sensors are smaller in size, plus you get immediately the processed data. So here, that's why these ceramics, semiconductor polymers, semiconductors, polymer sensors are most commonly used, not the usual regular metal or wire. Such things are usually, they are not used in all the applications. Depending upon the requirement, definitely they are used. Now, when you say that, okay, 10,000 of sensors are there, naturally those many number of techniques plus, may not be those many 10,000 techniques, but at least good number of techniques are required. Now, after knowing that, the efforts are being taken due to following reasons. Why still you go ahead with so many sensors and so many techniques? First thing is interaction between sensor and sensed media. Now, before this, I would like to show you how exactly these sensors work. Basically, whenever any biosensor or chemical sensor are used, you have this, the sample which is to be tested or which is to be sensed is here. Then it comes in contact with the transducer. So first thing, this is the one which is directly coming in contact with the sensor. When this mixture and the sensors, they are coming in contact, there are different varieties in this. So when it comes in contact, this may react with this and form another chemical compound there, or it may not react, just it may sense what are the available gas levels. And if it reacts with that, then you have again good number of other techniques which are to be used. If it doesn't react, simply it is going to give you the data like what is available, and it is designed for which gas sensor or which liquid level sensor. It is going to be giving you that data. Now when it comes in contact, then after this you have a transducer. So from this the data is collected, and this transducer is going to convert it to, most of the times it is electrical signals. So converting to electrical signals, and then as per what is the composition of this gas or a liquid, it is going to be calibrated, that electrical signal is going to be calibrated back into the number of particles or ppm or ppb, whatever. So here the transducer is going to be given and then to given to the detector in some cases. In some other cases, directly this is calibrated and given to the processor. What is the level? This is regarding the chemical sensor or biosensor, also similar lines it works. Now in this again you have two varieties actually. The ones which are magnetic in nature, for them different technology. The ones which are toxic in nature, for them different technology. And the ones which are not toxic and they don't react. So such ones you have another set. So like this you have in biosensor or chemical sensor category, you have variety of sensors available depending upon these toxic ones and non-toxic ones and the ones which react with the sample. Now we'll go back to the, now you can appreciate why exactly the efforts are taken. So many efforts are taken to manufacture the bio or the chemical sensors. Now interaction between the sensor and the sensed media. Directly as it comes in contact, naturally there is a possibility that it may get into the reaction and then produce another compound altogether. So it may be difficult to sense. Under such cases, what is the compound released or what is the gas released? Depending upon that, it has to be, the sensing has to be taken. The next one point is sensors are usually non-specific. Now some of the sensors are very, very specific and majority of the sensors are non-specific. Now non-specific in the sense like they are designed to cater to the needs of different levels. Suppose I want to sense nitrogen gas. Now nitrogen, where all it is available, they are going to be utilized there. So in that sense they are non-specific. It is not necessary that nitrogen in the air only has to be detected. For that you have a specific sensor, not always it is. Any sensor which can detect nitrogen or which can detect carbon monoxide level can be used anywhere. So in that regard, it is the sensors are usually non-specific. Now physical state of the sense substance. Now in gases it is going to be different because the reaction rate is different. In liquids again the reaction rates are different, plus the gases or the compounds liberated are going to be different. And similarly in solids the reaction may be lesser or the rate of reaction is lesser, but still different, the mixtures may be formed there. In case of solids, the formation of the mixtures is very much possible. So under such cases, physical state of the sense substance is also very important. Next, requirement of detecting and measuring the degree of concentration of the components. Now this degree of components only is essential or is the required thing. Everywhere now in air we have, all of us know that nitrogen, oxygen and humidity, H2O, those carbon dioxide, carbon monoxide are all present there. But what is the level? After say assume acid rain, what is going to be the level? Whether the ozone level has increased, oxygen level has increased, what exactly is happening? So the level is very important in studying. Even the gas, there is a small light gas leakage in the kitchen. Now under such cases, small leakage, okay, it is fine. Some people may smell it, some people may not. But if it exceeds certain limits, definitely within no time it is hazardous. And you might have heard recent that Vizag mishap. So even the Bhopal mishap, all those people could not sense only, and once they started sensing the levels were too high, so it is very difficult. So sensing the concentration of the components is very important. Now the next thing is requirement of sensor to be non-invasive. Now what exactly is non-invasive? Now invasive means the ones which you penetrate into the skin, they are called invasive, and the ones which are on the surface, they are non-invasive type. Now the usual sugar level testing, there are some patches available which are just you have to put them on the top of the skin and they test. Even the blood pressure monitoring or heartbeat monitoring, you are getting the nano patches which are of non-invasive type. So there you don't have to pierce or you don't have to use the needle to test the levels. Now this type are widely preferred here because every time putting into the skin is not always good, and it may not be practical also every time because you may need a trained nurse or a doctor. So if you have a patch, something like this, and then the sensor attached to it, it is very easy. Now all the smart devices these days, they are all non-invasive type. So you don't have to pierce into the skin. So that is regarding non-invasive. Then non-consuming type. Now non-consuming, all of you know. Medicines we consume, so they are consuming type. Non-consuming means without consuming that, the sensor, it should be able to read your say blood pressure, sugar level, heartbeat, anything. So such ones are preferred. And all these are smart watches and all, they make use of this non-invasive, non-consuming and non-interfering type. Simple, like a watch, I use it, and whenever I want, I just press a button, like this I want, this I want, this I want. So I can set it as per my body temperature requirements, I can set it. So they are customized. So these are the requirements today in sensors or smart sensors. So these are the basic requirements. So to fulfill these requirements, lot of efforts are being taken. The online real-time gas detection sensors are in demand in kitchen, and alcohol content detection using breath analyzer. These are some of the examples. And the most commonly used ones are semiconductor gas detectors and ion exchange electrodes are the popular chemical sensors which are used, and they are sometimes attached to a fixed like vehicle also, and from there you can test it, and some locking systems are also being made if the person has had more alcohol, then he will not be allowed to, his vehicle will not start. Such smart vehicles are also in the process of manufacturing. So they are all basically using these chemical sensors. You have lot of varieties actually in chemical sensors, and in association with that only you have these biosensors. Actually these two go hand in hand. Chemical sensors and bio, they go hand in hand. In some cases combinations are also used in some chemicals and some bio, but actually these biosensors, their life is very, very less. So they are not used in all these whatever 10,000 I said, they are in good number, but they are not used in that many. Only basically they are used in these food processing industries and all. Now we'll see what exactly these bio. Again, the working principle of chemical sensors and biosensors is exactly same. And you do have the again same classes in biosensors as well. Say toxic, non-toxic and magnetic, non-magnetic, that type. So biosensors also have the same class, and the working principle, as I said, it is same. So basically directly it comes in contact with the gas, liquid or solid under test, and from there either if it is chemically reacted, then what is liberated on the basis of that, how much volume is liberated on the basis of that, the further testing takes place and then converted to ppm or particles per mole or molecule or some specific volume, it is converted, and then the transducer gets converted. That transducer senses that and converts it to respective electrical signal and given to the detector. Then there the conversion from this to the chemical part or the biosensor part to the specific required gas level, it is converted. Now deals with basically applications to biological systems and organisms to manufacturing processes. Now manufacturing processes, you have several categories here where exactly this is in demand. Now first thing, preservations in food processing. Now we know very well that say suppose sodium benzoate or sodium metabisulfate, such preservatives are used. Now what exactly these preservatives are? They are nothing but chemical compounds. Sodium benzoate. So it is a chemical compound. If it is in certain more level, I think some time back you might have heard about the zinc level in Maggi and all. So that's why the Nestle was not allowed to sell the Maggi packets, because certain elements were above the health concerned or the above the health issue levels. So basically they were hazardous if they were continuously used. So such levels are tested using these biosensors. So here preservations in food processing industry. Now such preservatives we can see in jams, sauces and almost all these things, even in coffee powder, tea powder, if they are to be kept for longer time, preservatives are used. Even at home also we use actually the salts and all in pickles are preservatives. Even similarly the sugar level in case of some jams and all which are prepared at home, they are all preservatives. So certain level of preservation even at which is not hazardous to health. But if you put more amount of sodium benzoate or sodium metabisulfate, the sodium level itself in the sauces and all, it is hazardous, especially for BP patients or sugar patients, it is very, very hazardous if they use it continuously. So under such cases, preservations in food processing industry are tested using these biosensors. Now how exactly, again they are poured, and then some chemical reactions, definitely if they are above certain level they take place, and it is indicated in the form of color change or smell change. So basically some gases are going to be liberated and the smell is different from the regular ones. So like that these biosensors are used in preservations in food processing industry, and also biosensors are used as preservatives also. So next one, biosynthesis of useful products for pharmaceutical industries. Now pharmaceutical industry naturally antibiotics and all amino acids are generated. So with enzymes, artificial vitamins, so all these things, they are actually dependent on these biosensor technology. Now similarly, one more major application is biodegradation of unwanted and waste such as sewage treatment. Now actually this biodegradation of unwanted waste and especially the sewage treatment plants, they make use of these biosensors. Now what exactly the sewage treatment plants do? They actually, the sewage which is stored is treated using some chemicals, and this, how much it is being treated and how much it is useful, that those things are sensed by biosensors. Now reusage of toilet water and all, that is done by using these treatments only. So the water which is coming out, instead of wasting it, it is sent for treatment plant. There actually the biosensors are commonly used to test the level of the hazardous elements in them, especially the uric acid and all, which are eliminated or excreted from the body. They are present in the toilet water. So such ones, they are treated using some chemicals. Then after the treatment, whether the water is ready for use, to check that, these biosensors are used. This is very, very common application in almost all the treatment plants. So the next one, which we all know already, in the production of bread, cheese, beer, wine, all these things, the biosensors are used to check whether a particular level is, that's what I just now gave the example of your Maggi, so it falls in the same category. In the production of antibiotics, amino acids, enzymes, now already you might have heard like the COVID-19 virus, whether it is man-made or, so such things are also being tested using biosensors. So it is a debate is going on, but biosensors play a very, very important role in checking those, whether it is man-made or no, because every time the gene mutation, what is happening from one patient to another patient is different. So using biosensors, doctors are and researchers are testing what exactly is happening and what could be the next mutated one using the biosensors. These sensors have limited, the one biggest disadvantage of this is limited lifespan. Now why the limited lifespan compared to this? See, all our medicines, they have a expiry date. Why do they have expiry date? Because there are chemical compounds in them. So naturally with time, the reaction, whatever inside it happens, due to reaction, naturally the intensity or the concentration of the medicine level goes on depleting. So here even the biosensors also, they do have this expiry period. That's why they are very, very costly and they are not used in all the cases. But manufacturing, okay, they may take lesser, like the cost may be less, but because of this, to improve this quality, the cost is going to increase. What happens basically is, due to oxidation, a thin film is formed, and as a result of this, the sensitivity of the sensor reduces because there is a thin film formed of the oxide of whatever the chemical compound is there. So due to oxidation leads to biofilm formation due to reaction with the bacteria. Oxidation means basically the compound or the biomaterial which is used, which comes in contact with oxygen naturally. Simple, catching a fungus, that is one type of a reaction which forms a thin layer. So similarly here also in biosensors, something like that, how a thin film of fungus is formed on the food particles, here also similar case arises and you have this oxidation taking place which leads to expiry or the reduced lifespan of the biosensor. Now this same thing even in case of biosensor, it directly comes in contact with the material or the substance under test. Then the samples, they form some, here you can see here the molecules are of different type and here the molecules are formed. These are sensed and the transducer senses them, and these sensed ones are given to the detector, and detector analyzes, and whatever the calibration type is on that, it is going to display what exactly is the composition there. Now this is regarding the magnetic type of a biosensor. Now in the magnetic type of a biosensor, you have a magnetic material, and then you have this sulfur, gold, all these, and these when they come in contact with a magnetic material, how they react. On the basis of that, the sensor and the detector are taken into consideration. Now that completes your sensors. Now how exactly these sensors plus the different technologies are used in sophistication in instrumentation. Now what exactly this sophistication in instrumentation means? Now we have studied n number of sensors now and variety of transducers, both electrical, mechanical, and again in electrical we have studied active and passive transducers plus some mechanical transducers, and how exactly which order of the system they belong to, whether they are first order, second order, or any other like higher order. And the zero order systems, we have seen that they are the simplest ones, and most of them whatever we have used, they fall in that category. Now all the temperature sensors, definitely they are of the higher order type, either the first order or the second order depending upon the application and the complexity involved in attaining that particular temperature. So here in this we are going to see how exactly these are going to be making our instrumentation part simple and easy to use and safer to use. So sophistication in instrumentation basically deals with what? Basically we are in an era where speed is a requirement, safety is a requirement, and along with these two, security. If any information signal, that should be secured. There should not be any intrusion because we are using mobiles, so lot of data we are transferring from wireless, so security is needed there. Plus safety is needed because when I start keeping my mobile for charging, usually some 5 years back we would say that okay, night time don't keep it for charging, but sometimes it is so essential that only night time the charger and mobile come in contact, otherwise continuously you are using it on the screen. So in such cases safety is also important. Then speed, naturally 10 years back when we sent the data using internet, it would take hours. Movie downloading was taking hours, but now with fiber optic technology and high gigabytes of data transfer, of data transfer, within 2-3 minutes, yes, full movie is downloaded. So speed, safety and security, you can give n number of examples for this. What is the, why is the need and what is the requirement today, why it is so much essential. So the motto of this century is speed, safety and security. Now how to achieve these three using sophistication, or rather make our systems more sophisticated. Now basically what is helping us in doing this is miniaturization of the sizes. Now what I said, I often gave the example of LVDT. LVDT used for measurement of precise displacements was so much big in size. Now using a small micro button size sensor, we can sense the distances and of larger range, even non-invasive type there. You don't have to bring in also directly, say ultrasonic sensor. It can measure distances from few meters or millimeters to several meters. So such ones are possible, or sophistication is possible only because of such sensors. So miniaturization or even micro miniaturization of these components is helping or aiding in the sophistication of the instrumentation. Now miniaturization in the size of gadgets. Yeah, you can take example of TV or even computer. The first computer built was somewhat of this size, this room size. Now you can see the computer on your hand. So this is the advantage of technology plus again the miniaturization. All our VLSI technology is making the size of this, or the nanotechnology is making the size of all these components smaller and smaller. And even our SMDs and all, they are helping in producing the sophisticated instruments. So the result is your TV size is getting reduced, and good quality TV you are getting with smaller size. The cell phone size, naturally the screen, just because we want a bigger screen size we are using, otherwise the PCB which is there, it can be as small as even a few centimeter or inches. Now camera size also you can see, earlier we used to have big cameras, now small cameras. How many cameras are there in your modern cell phone? The higher end cell phones have how many number of cameras? 5, 6, so 3, and even zooming, many technologies, many techniques. So you have 3, 4 cameras minimum in your cell phone. So because that is size of the camera is very small, not even a button size. So all the glasses are there, plus your lenses are there, picture capturing capacity is there, everything is there. Again we say that 18 megapixel, 5 megapixel, 13 megapixel, all those, and front end, back end, all those cameras are again higher end only. So that is possible because of the micro miniaturization of the sensors. Now this, if you apply the sophistication to health related accompaniments, basically to monitor BP, we used to have that band and all, then the BP would be, the doctor would be pushing and pumping and then putting a pressure, then check the BP. Nowadays people have some accompaniments where they can test their BP in a different way using the sensors. Now sugar level, again I gave the example, often I have given this example, invasive and non-invasive type, the patches are there. Otherwise the glucometer, a small size glucometer is enough. Otherwise earlier people used to take the blood, go give it. Now this is not required immediately, you can test the sugar level then and there itself. Not necessary that your blood should be going to the doctor and then get it tested, the components and sugar level, urine sugar level, all those things. So here sugar level in the simple small glucometer of few centimeter size, immediately you can test it. You don't have to go to pathological or the laboratories or pathologists, no, not required. Now even the temperature. Now under COVID-19 at least the temperature has gained a lot of importance. So temperature using the sensors, the IR thermometers are being used and the temperatures are sensed. So very simple, you can sense the temperature. Now gas level monitors, yeah, these are often used in almost all the industries, and even in your kitchen also they are fitted. In some houses in the foreign countries they are compulsory actually, the gas level detectors and all. And even the gas masks, they are also compulsory in some industries where the gas levels vary continuously. So gas masks, and their size, they are fitted with the sensor and the size is very small. So headgears to warn about the toxic gases. So all these things are possible only with the micro miniaturization. This in turn is possible with the development in the our VLSI technology plus the nanotechnology. Now micro miniaturization of sensors through modern materials and modern manufacturing processes aids the design of sophisticated instruments. So the summary of this is, with the help of this kind of advanced technology, especially the nanotechnology, we are able to develop sophisticated small size miniature equipments to help the people. So the first one is the temperature measurements. Now in temperature measurements, we have good number of technology. Actually, even in mechanical also we have covered this temperature measurement, and electrical at least we have covered it a lot. Thermocouples to thermometers are regular thermometers which were used to measure the temperature. They all fall in first order category because of the time taken. Now these modern sensors which sense on the modern thermometers which sense on the basis of the IR radiations. Now how exactly these IR radiations help in this? See, thermometry and thermography deals with basically what? Radiation thermometers are designed to measure temperature of an object without any physical contact. Now earlier our old thermometers we used to keep them in contact with the body under measurement, whether it is human body or any other water also. We used to measure it bringing it in contact with the physical contact with that particular object. Now these days it is not required at all. Using the radiations, every human being emits radiations or the electromagnetic radiations are emitted. Similarly the animals which are breathing, they all emit. And even in these objects also, they do have some temperature, and that usually the ambient temperature and some corrections are made, and then the temperature of these is set. But human beings or which are breathing, their temperature using your electromagnetic radiation technique is measured, and it is measured with good accuracy. So all the objects with the temperature range from 0 degree, actually that should be 0 degree centigrade, 0 degree centigrade to 650 degree centigrade emit electromagnetic radiation in the infrared region. Now what is this infrared region? From 300 to 700 nanometers is our usual visible band. So 700 is the end of our red color. From 700 onwards to 1000 nanometers, it is our infrared band. Now all the objects with the temperature range from 0 to 650, they emit these infrared radiations ranging from 720 micrometers to 1000 micrometers in this range. 700 nanometers to 1000 micrometer range. So they emit certain radiations. Now because of these radiations, what happens? The total energy emitted within this spectrum of wavelength increases with the temperature. There is a fixed calculation, like this particular temperature is going to emit so much of radiation and the energy level of this is going to be so much. So on the basis of that energy level, it is calibrated to temperature. This is what is the technique. So this emitted energy is converted to temperature, and a particular body with so much temperature is going to emit so much energy, and that is converted back or calibrated back into the temperature. So the total energy emitted within this spectrum of wavelength increases with temperature. If the temperature of the human body is more, so regular our temperature is 98.6. normal temperature. If it is 99 or 100, then the amount of energy emitted will be increasing. So the total energy emitted within the spectrum of wavelength increases with temperature. If the energy emitted is more, naturally the temperature is also more. So the calibration is how much energy is emitted for a normal temperature and how much energy is emitted for an increased temperature. So this is how the calibrations are done and they are given out. Now the total So due to this, what is happening is the temperature sensing need not be coming in contact, your thermometer need not come in contact with your body, or even like with some distance also you can measure. Only thing, there are certain rules, like if the distance is too much, then the radiation of the energy will be lost into the atmosphere, so it may not be accurate. Again, to make it more accurate, there are some correction factors which are associated or added to give the correct temperature. Now daily, actually the temperature of every employee is being monitored everywhere in whichever organization they are working, and through this kind of a thermometer only. So daily we are measuring the temperature almost, like if the person's temperature is more, then naturally it shows you different energy level. So this is what even in the airports and all, these are being tested daily. So here you have a good example where the IR radiation thermometry is utilized. Now there are several challenges in the design of radiation thermometer. Now the one which comes in physical contact, you can always say that again, it was told that okay, whenever you kept the thermometer in mouth and all, you kept that close the mouth. Why closing the mouth? Because the temperature which is coming out should not, again the cold air which is outside compared to the body temperature should not reduce the temperature. That was the idea. So you were told to close the mouth whenever the thermometer was kept below your tongue. Now, when it is in open, when only the skin temperature is being tested, naturally skin is coming in contact with air naturally. Suppose if you are coming from AC, again your skin is having lesser temperature than your normal body temperature, plus atmosphere is also contributing to it. If it is cold outside, naturally the cold air, amount of energy you are emitting or the body temperature which you are having will be lesser. So as a result, what is happening? The amount of energy emitted is reduced. So naturally the temperature which is being sensed is naturally reduced because the amount of energy reaching the sensor only is reduced. Okay, this is one aspect. Second thing is, naturally sensor means it is going to pass through some glasses, mirrors, lenses. So all these naturally absorb some energy. So whatever I am emitting, some amount of energy is being absorbed by these substances. Say glass is there, plus some lenses are there to focus and to convert this emitted energy into temperature, again there are conversion losses. So as a result, more losses are going to be definitely there. Some correction component or compensating network has to be there to compensate for this. So because of this, there are many challenges. Plus the surface. Now skin surface, most of us, okay fine. But if it is an object, it can be rough, it can be smooth, texture may be different, or shape may be different, size may be different. So because of this, there are many challenges in getting the accurate results out of these sensors. So we'll see some of those challenges. So it is essential to affect calibration against black body reference for each application. Now what exactly this black body reference? Now when my energy is being sensed, whatever amount of energy I am radiating is being sensed, naturally it has to be compared with some standard. Now how we set the time? With some standard clock we set the time. Similarly, with some standard temperature radiating body, whatever amount of energy is radiated, from that comparison should take place and then the comparison should yield you some result. Here commonly the black body reference is used for every application, means each time a person is being tested, every time it has to be compared with this. So there is a comparison network and that has to be maintained at a proper level. If there is any problem with that body, then all the results will go wrong. So essential to focus the radiant energy from the body under measurement to a point through the application of filters, lenses and mirrors, which leads to certain loss of energy. So all these loss of energies should be considered while calibrating or while displaying the temperature. The object may not always be stationary. If it is moving, the time duration of exposure needs to be considered. Yeah, usually the temperature, why we call it as a first order system is because it needs certain time. Whenever the thermometer also comes in contact, we keep it for few minutes, 2 or 3 minutes it is kept. So when you keep in contact, naturally it has to attain that body temperature. Only then the mercury level or the alcohol level increases. Now if you remove it at a faster rate, say after 1 minute, it might not have attained the actual level. the reading will definitely go wrong. Similarly, in this case also, how long it should be exposed to the sensor. If it is fast moving, then the readings may not be correct. So you are made to stand. In some cases it may not be possible. Under such cases the results may be wrong. So it is a challenge, or fast reading may not be possible. The object may not always be stationary, and if it is moving, the time duration of exposure needs to be considered. If possible, make the object stationary and then do it. If not, then see at least how much minimum time it should be exposed to sense, or your sensor should be again more faster. The object under consideration vary in size, shape, smoothness of the surface and the material of the object. So the sensitivity in reception is different in each case. So for each of them, the sensitivity of the same sensor or the same thermometer may be different depending upon the case. The path of the radiant beam cannot always be air. Yeah. Again, air composition also matters a lot. If air composition, if it is humid, then the absorption of energy radiated is more. If it is very, very hot, then it may contribute to the, or it may add to the temperature. So even the same air also, depending upon the period or the season, the calibration has to be different. In summer, it may be different calibration. In winter, it may be different calibration. In rainy season, because naturally, if it is assuming that if it is raining but still it is being tested, then due to water medium, the energy level which is being transmitted, the electromagnetic energy which is being transmitted to the sensor, it may change. So depending upon this, you have to calibrate the sensor as per the need, as per the season and as per the medium in which you are working. Again, if it is swimming pool, then naturally in the swimming pool definitely water is there. So water, due to that the energy radiated will be absorbed by the water, plus transmission due to that energy through water is also difficult. So the calibration basically has to be set as per the atmosphere or as per the ambient need. So path of radiant beam cannot always be air. Water vapor and other gases such as CO2 in the path may result in loss of energy because the absorption of heat or the energy there is more. So the proximity of other objects this is one more good point. Other objects at varying temperature causes error. Now if I am in the classroom, naturally there are no much of absorbance or they are not giving out heat to me. But if I am in the vicinity of a furnace, then naturally that furnace temperature also gets added to it, or not exactly in the vicinity, even if I am away from half a meter away from it, but still it adds to the temperature. So it depending upon that, the proximity of other objects at varying temperature. Now here the temperature of almost all these desks is same, so the ambient temperature is same. So naturally if it is measured every day, it may remain same. But in other cases, if I am near somewhere a water pool or a steamer, then it may be different. So those things have to be taken into consideration, and then accordingly calibration has to be made. Yeah, in the next class we'll deal with this nano instrumentation.